My topic is today. My topic is acid-base chemistry. Acid-base chemistry is about basic organic chemistry, and this is very much important for NEET, JEE, JEE Advanced, and AIPMT, for many entrance examinations. In case of acid-base chemistry, this is important case of both inorganic and organic chemistry. When we are studying organic chemistry, the importance of this is that organic molecules are not soluble in aqueous media all the time or ionic solvent all the time. So we should use organic solvent. But if we want to solvabilize that organic compound, we should convert them in their anion or their cation, and that very much depends upon their acid and base acidity and basicity, and depending upon the pH range we can dissolve a compound or can precipitate or can form precipitate of that compound. For acid-base chemistry, the point that is important is conjugate base or conjugate acid. Acidity or basicity very much depends upon stability of conjugate base or conjugate acid. So, the main point is stability of conjugate base or conjugate acid. Now, acid. Now, what is conjugate base and what is conjugate acid? Suppose we take an alcohol, ROH, that generalized form is ROH. And when I'm adding some base to it, suppose B, and it forms RO minus, that hydrogen get abstracted by that base and forms O minus. So, base is reacting with the acid and forms a conjugate base. So RO minus is conjugate base of alcohol. Now suppose RNH2 and primary amine, if I treat it with acid, suppose H plus, it will form RNH3 positive. So NH2 captures H plus and form NH3 positive. So that RNH2 is the base and its conjugate acid is RNH3 positive. So hence it is conjugate acid. Now what is acidity or basicity in case of that organic compounds? Acidity means proton release. The smooth proton will get released, the more will be acidity, and basicity means affinity towards proton. More the affinity towards proton, more will be basicity. Now I will go to some simple example. Okay, before going to some example, I want to say that what I said about stability of conjugate base or acid, that stability of conjugate base or acid very much depends upon delocalization power of conjugate base or conjugate acid. Suppose 4 acids, that is hydrochloric acid, suppose hydrochloric acid, HCl. When HCl is a gas, then it has no acidity. But when it is in water, in aqueous medium, it will form H plus and Cl minus, then it will show its acidity. And in case of basicity and acidity, solvent is very much important. As chlorine is electronegative element and negative charge is very much stable upon Cl minus, hence we can say that HCl is a strong acid. But HCl is stronger than what? HCl is stronger than acetic acid, but again HCl is weaker than H2SO4. So the stronger, weaker, that are relative term, they are not absolute, they are relative to one another. Now some examples: hydrochlorous acid, chlorous acid, chloric acid, perchloric acid. First of all, hydrochlorous acid. hydrochlorous acid, that is HOCl, chlorous acid, that is ClO2, HClO2. Chloric acid is structure is very much important. When I'm telling, perchloric acid is HClO4. When it is HOCl and OH is bonded with chlorine. When it is HClO, Cl double bonded O and OH. When it is HClO3, it will be Cl 2 double bonded O and 1 OH. When it is HClO4, Cl 3 double bonded O with 1 OH. So they are monoprotic acid. Monoprotic acid means only one proton to give, one proton to donate. And when it donates its one proton and give that conjugate base, it will form O negative Cl. It will form O negative Cl double bond O. It will form O negative Cl 2 double bonded O. And it will give you chlorine with 3 double bonded O. And this negative charge can go to conjugation with that carbonyl compounds. And this negative charge will goes conjugation with 2 double bonded O. And this negative charge with 3 double bonded O. So, in case of suppose O negative, chlorine, double bonded O and double bonded O. Once conjugation, then give then again, then it will give then again. So in case of perfluoric acid, 4 equivalent structures are possible. So in case of perfluoric acid, 3 equivalent resonating structures are possible. Like that way, when it is chloric acid, it will give 3 equivalent resonating structures. More equivalent resonating structure, more will be stable that anion, that conjugate base here. And here in another way, that negative charge is delocalized between 4 oxygen atoms. For chloric acid, negative charge is delocalized between 3 oxygen atoms. For chlorous acid, negative charge delocalized between only 2 oxygen atoms. So more the delocalization, more stable will be conjugate base. Hence, according to stability of conjugate base, perchloric acid has highest acidity and hydrochlorous acid has lowest acidity. And from hydrochlorous acid to perchloric acid, acidity increases. Now our second example, example 2. Example 2 means acidity comparison between some organic acid. Suppose first of all alcohol, aliphatic alcohol, ROA suppose, then aromatic alcohol, suppose it can be phenol, PHOH, and carboxylic acid. That basic example, that basic concepts are very much needed for any competitive exam, and you have to clear your basic concepts first. ROH for alcohol, when it treated with base, it will give you RO negative. There is no conjugation, there is no extra stability, so it is just a very mild acid compared to phenol and any carboxylic acid. That can be aliphatic carboxylic acid. I will come about later. About phenol, when it is phenol, as we all know, it is OH and its conjugate base is O negative, that is phenolate. It is called phenolate. In case of phenolate, it has a resonating stability and it will goes to resonance like that way. Negative charge and that way, and that negative charge is delocalized over whole phenolate, whole benzene ring and oxygen. So due to stabilization due to extra stabilization of resonance stabilization, aromatic alcohols, especially phenols, are more suppose if it is our ethanol, ETOH so phenol is much more higher acidic than ethanol. Now coming to carboxylic acid. That carboxylic acid can be suppose acetic acid can be aliphatic carboxylic acid, and it can be any aromatic, suppose benzoic acid, phenol ring and CO2H. When it is aliphatic carboxylic acid, base CH3, C double bond O, O negative, that is its conjugate base. Base abstract that hydrogen and gives an anion. Now it will goes to resonance. Acetic acid, CH3, CO negative, double bonded O. It has only two equivalent resonating structure. But the fact is, acetic acid is much more acidic than phenol. Then what is the reason? In case of phenol, there is more than two resonating structure. Even there is many, when it will resonate like that, there is many resonating structure and more than two. But when it is acetic acid, it forms equivalent resonating structures. Two resonating structures are completely equivalent. But in case of phenol, negative charge comes once para position, then ortho, para, ortho alternatively, and all phenol resonating structures of phenols are not equivalent, so that acetic acid much more higher acidic than phenol. And of course benzoic acid is also higher in acidity than phenol. Now for at aliphatic alcohol, pKa value is near about 15. For phenol, pKa value is near about 10. For acetic acid, its pKa value is near about 4.8. More the pKa value, lesser will be acidity, and less the pKa value, more will be acidity. And pKa, as pKa is equal to minus log of Ka, more Ka, higher the Ka value, higher will be acidity, and higher the Ka value, lower will be minus log Ka, and lower will be pKa. So lower the pKa value, more the acidity. Always remember that. Now some nitrogen based acid. And another point is, more the acidity, lesser will be basicity. That is in case of some, not for all compounds, but that is applicable for that compounds about which I am going to discuss. That is aniline. At first aniline, our comparison will be between. Now for aniline, its conjugate acid, conjugate base, that is NH negative, that can go to delocalization. And again for piperidine, it will form also, and the negative charge will also come to that in. But now this pK value is regarding its protonation, means is its conjugate base formation. Okay, and from the pK value we can understand that it is very much mild acidic. And in case of piperidine and pyridine, this pK value 13 and 5.5 are pK value corresponding to their protonation. Not that can be, we can say that pKb, actually not, this is pK. More the pK value, more will be basicity here. pK value corresponds protonation. That pK is associated with their protonation. If I give their proton, then in H2 positive will form. If I add in pyridine, it will also capture an N and NH positive. And from here we can see pyridine is lower in basicity than pyridine. Pyridine is higher in basicity, so aniline is mild acidic, and as that aniline lone pair can goes to conjugation with aromatic ring, so aniline is less basic than both pyridine and pyridine. Now about pyridine and pyridine. Pyridine is more in basicity than pyridine, because in pyridine nitrogen is sp2 hybridized. In pyridine, that secondary amine, nitrogen is sp3 hybridized. More p character, more the electron want to be in that orbital. It don't want to share its proton with any electron with anyone, and it does not want to share its electron to its proton, and hence it is not want to form a protonated conjugated acid. Okay, as sp3, so lesser, about 3/4 of p character in nitrogen, sp2 2/3 of p character in this nitrogen. As sp2 nitrogen has more p character, it is less prone to give its electron to proton. So as and that conjugate acid of pyridine is more stable than pyridine, and hence pyridine is more basic than pyridine. Now substitution, how substitution affects acidity. Suppose phenol and in phenol and nitrophenol is more in acidity than phenol because of NO2 group. As when their conjugate base forms, that negative charge go extended conjugation with that NO2 group, which has minus R effect, and due to minus R effect, it has more stability in that conjugate base. Hence nitrophenol, para-nitrophenol is more acidic than phenol compound. So generalization is like that. First of all, conjugate acid, conjugate base stability. Then conjugate acid that forms from a base stabilized by donation. Suppose ammonia and methylamine. In between ammonia and methylamine is more basic than ammonia, because if it captures one proton, it will form NH2 positive. It will form NH2 positive. It will form NH4 positive, NH3 positive with CH3. As CH3 has plus I effect, it will stabilize that its conjugate acid. Hence, methylamine will become more basic than ammonia. And the another factor is that conjugate base forms from acid stabilizes by any withdrawing effect. Suppose minus I, minus R effect, like phenol and para-nitrophenol. Now, one example of AIPMT 2016 question: basicity of aryl amine. Aryl amines are generally more basic than alkyl amine because nitrogen lone pair electrons are not delocalized by interaction with aromatic ring pi electron. Option 2, aryl amines are generally more basic than alkyl amine because of aryl group. Option 3, aryl amines are more basic than alkyl amine because of nitrogen atom in aryl amines is sp hybridized. And option 4 is aryl amine are generally less basic than alkyl amine because of the nitrogen lone pair electron are delocalized by pi interaction, that interaction with benzene ring, aromatic benzene. So it will be aromatic ring. Now the right option is option 4, because alkylamine and arylamine. Suppose we take CH3NH2 and PHNH2. As there is question of basicity, so one H plus will be accepted by that nitrogen lone pair. It will give CH3NH3 positive, and it is NH3 positive. Now conjugate acid stability. This is their conjugate acid. And in case of methylamine, when it is NH3 positive, that electron deficient center gets stabilized by plus I effect of CH3 group. And in case of arylamine, that nitrogen lone pair goes conjugation with phenyl ring, aryl ring. And now that lone pair as involved in that delocalization, so that lone pair is less available towards one proton, and it has less prone to proton, and when it's come to its conjugate acid, that anilium ion conjugate acid, that delocalization is no more possible. Hence conjugate acid is less stable than that base, and here conjugate acid is more stable than that base, because it is stabilized by plus I effect of CH2 group. So conjugate acid of methylamine is more stable than arylamine conjugate acid of alkylamine. Conjugate acid of alkylamine is more stable than conjugate acid of arylamine, as conjugate acid is more stable in case of alkylamine, because in case of arylamine, nitrogen lone pair is involved with delocalization of ring, hence alkylamine will be more basic. Hence that option 4 is right. That is, arylamine are generally less basic than alkylamine, because the nitrogen lone pair electrons are delocalized by interaction with the aromatic ring pi system. Thank you. And again, I want to say that basic concept is very much important in case of any competitive exam. That can be AIPMT, that can be JEE Main, any of them. And best of luck, student. Thank you.